Hello everyone. In this video we're going to be solving a differential equation. We have dy over dx equals the square of x plus y minus 1, and we're going to be solving for y values. Now let's go ahead and approach this problem in kind of two different ways, one of which is using substitution. So I can go ahead and call this thing u. So x plus y is equal to u. And from here, we can differentiate both sides. Notice that y is a function of x, so we can talk about dy over dx, which is the derivative of y with respect to x, right? And u is also a function of x because we're adding x to a function of x. Make sense? Now, if you differentiate both sides here, you get u prime equals 1 plus y prime. And from here, we can isolate y prime and write it as u prime minus 1. Awesome. Let's go ahead and make the substitution and let's see how we can solve it from there. Y prime is definitely dy over dx, so we can kind of write this as y prime equals x plus y squared minus 1. Now we're going to replace y prime with u prime minus 1 and x plus y with u, so it's going to be u squared minus 1. And then we can go ahead and cancel out the negative ones, and we end up with u prime equals u squared. So can you think of a function whose derivative is its square? That would be a good question, right? It might be hard to guess, but go ahead and make a guess at this point. Write it down because you can check your answer against mine, okay? So let's go ahead and write u prime as du over dx, which is Leibniz notation, right? That kind of makes things more clear and also allows us to turn this into a separable differential equation. Because if you had u prime equals x squared, then from here you could easily deduce that u is equal to x cubed over 3 plus a constant. Why? Because the derivative of u is x squared, so all you have to do is integrate with respect to x. But when the right hand side is something else, another function squared, unless you know what that function is, you can't really do this. And you're looking for that function, so you don't really know what u is, right? Or u are? U is, yeah, okay. Now let's go ahead and put du over u squared on one side and dx on the other side. Now we were able to separate the variables, and now we can go ahead and integrate. Separable differential equations are one of the easiest types because all you have to do is separate and integrate, okay? Provided that there's an easy antiderivative. Now we have the integral of 1 over u squared. Think about it. The derivative of 1 over u is negative 1 over u squared. So this will be actually negative 1 over u. By the way, I'm not going to use a constant because I'll put that at the end. And then this equals x plus c. Awesome. Now how do we simplify this? Before we back substitute, let's go ahead and simplify as much as possible. I could probably just multiply both sides by u. That'll give me negative 1 equals ux plus cu. Or I could still leave the u as separate, maybe. I don't know. And from here, we can either put everything on the same side or use back substitution. What do I mean by that? Is because we call this u, x plus y is equal to u, now we need to replace u with x plus y. So u is equal to x plus y here and here. And if you wanted to take out a u, that would be okay too. So you could also write this as u times x plus c. No big deal, right? Now, if you replace u with x plus y, you get negative 1 equals x times x plus y plus c times x plus y. And a lot of times we want to isolate, right, the y, so we can write the y by itself. In this case, you probably want to do that. So let's go ahead and actually do this beforehand. And I'm going to go ahead and first, just factor out a u and then write this as x plus c, like here. And then I'll do the substitution. Negative 1 equals x plus y times x plus c. Since I'm trying to solve for y, let's go ahead and divide both sides by x plus c. So that gives us x plus y equals negative 1 over x plus c. And then from here, y is going to be negative 1 over x plus c minus x. C is a constant. We said that, right? It's an arbitrary constant. And our function y can actually be expressed as this, right? And c can be pretty much anything, unless we're given initial conditions like, you know, the value of y at 0 is blah, blah, so on and so forth. We're not going to be able to find c. C is going to be just an arbitrary constant. But a lot of times in differential equation problems, especially if it's applicable math or some type of application, then we're usually given some conditions so we can find the value of c. Anyways, this should be the answer, right? So one of the things that I'd like to do is, I mean, you don't have to do this, but you can definitely make a common denominator. That's going to give you negative 1 minus x squared minus cx divided by x plus c. And I could probably write it in a more standard way, negative x squared minus cx minus 1 all over x plus c. Now I want you to go back to the original problem, which was what? You remember what the original problem is? I forgot. dy over dx, okay, here we go. dy over dx equals x plus y squared minus 1. Now here's a $1 million question. Does this equation, or does the solution, satisfy the original equation? And we can definitely find out by substitution, right? How do you differentiate something like this? To differentiate this, we're going to use the quotient rule. The derivative of the numerator times the denominator minus the derivative of the denominator, which is 1, times the numerator. And all of that is divided by x plus c squared. You can simplify this a little bit, right? If you distribute, you're going to get negative 2x squared minus 2cx minus cx minus c squared plus x squared plus cx plus 1 all over x plus c quantity squared. Now let's see what we can do with that. From here, y prime is going to be negative x squared. I can kind of combine these two things. And then minus, by the way, this cx and negative cx cancels out, minus 2cx, and then we have minus c squared plus 1. All of that is divided by x plus c squared. Now the question is this the same thing as x plus y squared and then minus 1? Obviously, you can add x to both sides and then square it and subtract 1, but that's going to be a lot of work. Instead, let's go ahead and work on this because this is workable. Look at this. If you take out a negative 1, this will become x plus c squared. You see that? It's awesome, right? And then by doing this, you can kind of separate this into two pieces like this. Y prime can be written as negative 1 plus 1 over x plus c squared. Now we can go ahead and compare this to the original equation. So this is y prime. If I add 1 to both sides, what am I getting? I'm getting x plus y squared. Am I? So that should be x plus y, and it actually is. So our solution satisfies. I just want to quickly show you another way to approach the problem, even though it's not entirely different. Just a quick way to look at it. You can kind of put the one on the left-hand side and then think of this as follows. This is the derivative of y plus x, isn't it? Now, this will be a really cool way to substitute, obviously, and this kind of makes more sense, right? Why we used u as x plus y, and then from here you get u prime, which is dy over dx equals u squared, and the rest is pretty much the same. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.